Hi ladies, in this video we're going to go through 5D, which is scalar multiplication. With matrices there's two types of multiplication. There's what we're going to do in this video, which is scalar multiplication, and then there's matrix multiplication. Scalar multiplication is extremely easy. When I say extremely easy, as long as you can multiply, you can do scalar multiplication. Matrix multiplication, on the other hand, is a little bit more, I wouldn't say confusing, complex. Complex is a good word. Okay, so 5D, if you've grasped scalar multiplication, don't think you're going to be fine for matrix multiplication. Make sure when you watch the video on matrix multiplication that you really understand how to do it, because it is a lot more complicated. Anyway, let's get started. So I might just make this a little bit bigger so I can actually read. Oh, excuse me. Did I make that bigger? Let's just make the whole thing bigger. Okay. So a scalar is just a number, and scalar multiplication is when you multiply a matrix by that number. So when you do a scalar multiplication, every element inside the matrix is multiplied by the scalar. So you can see here we have a matrix multiplied by k. So every element, and you can see the elements are just allocated lowercase letters. So in this case, A. Every element is multiplied by k. So you can see here on the matrix on the right-hand side, it's k times this first element, k times this element, k times this element, and so on. Now you can do it in your calculator. So let me just make it a bit bigger so you can actually see it, although you probably have it in front of you. It's good to allocate, if you're doing several manipulations of a matrix, it's good to allocate it or store it as a matrix. So we went through that in a previous video. So basically you just go to store and you store it as a give it a letter. So sometimes a matrix will already have a letter. You can see here matrix A and matrix B. So in your calculator, you can call it matrix A and matrix B. And then you can manipulate it. So you can do A plus B, A minus B, 9 times matrix A, 15 times matrix A minus 11 times matrix B. And your calculator will do it for you. So I'm going to skip through that because you can do that yourself. You can read an example. So we're going to do these examples and we're going to do them by hand. The important thing doing it by hand is, and when I talk, I know we're in year 11, but let's talk about year 12. You need to understand what is happening, because often you'll get questions on an exam that require you to understand what is actually happening. Sure, everyone can put something into a calculator, but do you actually understand what that calculator is doing, what that calculation is? Okay, so here we've got matrix A, and I just realized I can't write on the, oops, using my wrong thing. I'll just put it there so I can write on the Word document. We've got matrix A, and we're multiplying matrix A by a scalar of 4. So I'm going to do a nice big matrix. It's probably a good idea to do your brackets at the end, but I've already started drawing them. Now every element is multiplied by 4. So I'm going to just quickly rewrite this matrix. And I can hear my son singing downstairs, so shutting my door was a good idea. Okay, so we're multiplying everything by 4. Okay, so you are probably sitting there thinking, oh, do I really need to do all this working out? You need to understand what is happening. So every element is multiplied by 4. But I guess in terms of working out, you could probably sit there and know that 4 times 3 is 12, 4 times 11 is 44, and so on. So you don't really need to do that step if you can do the multiplication in your head. Okay, so I'm going to quickly do that. Hopefully I can do the multiplication in my head and talk at the same time. Okay, and there it is. So you can store it into your calculator and then go for A. Sometimes things are a lot quicker to do by hand, especially when it comes to matrices, but because by the time you turn your calculator on, put the matrix in, store it, multiply it by 4. And by the way, you don't need to store it to multiply it by 4. You just go 4 times. But yeah, so my point was sometimes it's quicker just to do it by hand. Okay, question 2, and let's just scroll over so we can see part B. All right, I might write a bit smaller too because I might not have room. Okay, so question A, we're doing 2A plus 4B. Okay, so 2 times everything, so 2 times 3, 2 times 7, 2 times 1, 2 times 8. I strongly encourage you to probably do it by hand and then just check your answer on your calculator. And then we're multiplying matrix B. So 4 times -1, 4 times 9, 4 times 2, and 4 times 5. Again, you could do that in your head. Okay, but I wanted to show you what I'm actually doing. All right, so let's just quickly do that. Hopefully not making any mistakes. Okay, something like this would probably be quicker to do on the calculator. There we go. And don't forget, we're adding them together. So we've done the scalar multiplication. So do the scalar multiplication first and then do your addition. So remember, we can only add matrices when they're the same order, and these two are. They're both 2 by 2 matrices. So we go, I'll write them working out. So 6 plus -4, so the elements in the same spot are added. 14 plus 36, 2 plus 8, and then 16 plus 20. So kind of think if they were over each other. So the matrix was on top, so in the same spot we're adding. Each element in the same spot is added to the element in the matrix on the other. Yeah. Okay, so 6 plus -4, it's 2. 14 plus 36, what is that, 50? It's a weird looking 50. 10, and then 36. Okay, and there's your matrix. Okay, so I'm going to just get another page. And I might get another 2 pages because usually I've started doing that before I start the video, so I don't have to keep doing page. But anyway, so this time we're doing 3A. We're doing question B, 3A minus 5B. So if you want, you can do it as you go. So 3 times 3 is 9. So I'm just multiplying everything in this matrix by 3. 3 times 7 is 21. 3 times 1 is 3. And 3 times 8 is 24. And we're subtracting 5 times B. So 5 times -1 is -5. Then 45, 10, and 25. Okay, so everything in matrix B, because it's 5B, is multiplied by 5. Now, remember, subtraction, you can only subtract matrices of the same order. They're both the same order, 2 by 2. So we've got 9 minus -5, so that becomes 9 plus 5, which is 14. 21 minus 45, oh gosh, it's requiring me to do a bit of thinking there. 3 minus 10 is -7. And 24 minus 25 is -1. And we put our square brackets on. Scroll, scroll, scroll. Okay, so here is a, excuse me, an application question. Okay, so a company is raising the wages of their employees next month by 30%. I've already read the question, so I know it's 30%. Now, if you're increasing something by 30%, you're basically increasing it by 130%. Okay, so you're multiplying it by 100%. Because if I multiplied it by 30%, I'm only going to get 30% of that number. So if you think of, all right, they had $100 and you're increasing it by 30%. If you took 30% of 100, it's 30. Okay, so you can add that back on, but it's the same as multiplying it by 130%. So the 100% allows for what you already have, and the 30% is your additional. So it's 100% plus whatever we want. So in this case, we want an additional 30%. And if it decreased, then it's 100% minus that. Okay, so our scalar multiplication, don't multiply it by 130. We've got to write it as a decimal, so it's 1.3. And then we've got 6.5. Now I'm already thinking I'm going to do this on my calculator. Even though I'm doing decimals at the moment with my year 7s, you probably don't want to be sitting here while I'm doing all these multiplications. So let's just put the 0 on there. Let's be consistent. Okay, so I'm going to pause just while I open up my calculator. All right, so I've just got my calculator. We're just doing normal calculation. We don't need to store this matrix because we're only dealing with it once. If we were dealing with it several times, then we could. So I just write 1.3. Okay, so I just write it as it is written here. The scalar always goes at the front of the matrix. So 1.3 times, and then I draw my matrix. So there are 3 rows, 2 columns. So let's do 3 rows, 2 columns. Remember, if you accidentally do it around the wrong way, it always shows you on your calculator, so you can always check if it looks the same. When you go to the next element, use tab. I find using arrows a bit of a pain in the butt, so tab is just good, a lot easier, and a good habit to get into. So the tab key, you can see, is now red, just here above the control. What do we got? 15.5, and then 22.3. Okay, and then just press enter. And there is, what are we calculating? The new wages? I can't remember. So there we go. All right, I was just checking while my calculator was uploading a question from the textbook. So some of the questions we do in this booklet aren't that difficult. So I'm going to just do a few questions from the textbook. So I'm going to upload the textbook, maybe pause. All right, so just looking through question 5. So we've got expenses arising from costs and wages for each section in 3 stores, A, B, and C, and at the cost. So we've got a shop that sells clothing, furniture, and electronics. So you could say like Maya. The costs involved for each section, they're $1 million. So 12 million, 10 million. And then the sales, so how much they get in revenue, how much they make from selling their product. So for question A, write a matrix showing the profits in each section of the store. So when we're dealing with costs, revenue, and profit, the profit you make is just how much money you get from your sales minus the cost of producing that. So let's say we had our own business and we were selling dresses that we made. It cost me $50 to make each dress, and then I sold them for $80. So I'm making a profit of $30. So to calculate that, I just take the 80 minus 50, the revenue, the sales, minus the cost. So for this one, excuse me, you've got your sales matrix and you're going to subtract your cost matrix. Okay, I'm not going to do it. I'm just going to talk you through it. So question B, if 30% tax must be paid on profits, show the amount of tax that must be paid by each section of the store. No tax needs to be paid for a section that has made a loss. So remember, first of all, we've got to identify any losses. Now, just by looking at this, you would get a loss if your cost was greater than your sales. Now, the only one is in store C for furniture. It cost $14 million, but they only made sales of 13 million. So in that matrix that you're going to be multiplying by the scalar product is 0. So you're going to put a 0 in this element because it comes out as -1, but we don't charge tax on negative profit. Okay, so just that's the only thing is when you have your profit matrix, you're going to have a -1 in this element. So just change that to a 0 when you're dealing with question B. Now we've got 30% tax must be paid. So the previous example, it was increasing by 30%. Here, we're just finding out the amount of tax that's paid. So we're just going to find out 30%. So as a decimal, 30% is 0.3. So your scalar product is 0.3. Now, girls, if you do have the online resources, just remember the solutions are here as well. I actually wanted to check what they were doing with question B, because technically, if you're using a profit matrix, you can't just change values. You've got to do another matrix multiplication or something to make it 0. But I thought, well, let's just see what they did. So if I go to the solutions, which I think I already had open, let me just check. No, not there. There we go. So you can see here the 0 that I was talking about. Okay, so the 0 for no profit. And then here you've got your tax because you're multiplying by this scalar. And you can just do that on your calculator quite easily. All right, girls, I'm going to end it there. Catch you later.